Okay, welcome back to part 2 of this video. Sorry, I had to get out of here to start teaching a class and everything. This is part 2 of the video. What we are doing is we are analyzing the area of this x to the fourth, which is the W shape, and this parabola, which is that red shape. And what we've determined is the easiest way is to work on this this right-hand side of this. And what we're going to do is we're going to find this area of this area, which is the blue over the red, and then we're going to add the area of the red over the blue. So this is going to be on the interval from 0 to 1, and then 1 to 2. And then we're going to flippy-flop it. And then we'll notice that this indeed we'll just double this area because it'll be the same as what's to the left because it's symmetrical. Okay, so we set up the first integral from 0 to 1, so that is that area right to the left here, and then we're going to set up this area to the right. Okay, so let's go ahead and set that second area up. So I'm going to add the area that is from 1 to 2, and that is going to be the red over the blue. Now, keep in mind that what we're going to do is we're going to smash this down a little bit so I can get some working room here. The equations get a little bit long. Sorry. You can read that. You're a better man than I. Need to clean up my mess here. Okay. So this was the x, and then what we're going to do is we're going to multiply this entire thing by 2. Okay, so this left-hand side, this is what, x to the fourth minus 5x squared minus 4. And this is probably the exact opposite, so negative x to the fourth minus 5x squared minus, sorry, the first one was a plus 4, this is a minus 4. And this is all multiplied by 2. No, I should have an exact opposite. So this is, sorry, yes, this is a plus. Man, you get better. All right, so yeah, so it's an exact opposite. All right. So long story short, this is 1/5 x to the fifth minus 5 over 3 x to the third plus 4x. This is on the interval from 0 to 1. And this one is negative, that's an x to the fourth, negative 1/5 x to the fifth plus 5 over 3 x to the third minus 4x, and the exact opposite. And this is from 1 to 2. This is all getting multiplied by 2. Let's get a little bit more working room. All right, so here comes the calculator. So the first one is starting evaluated at 1, and so this is 1/5 x to the fifth minus 5 over 3 x to the 3 plus 4x. Repeats. Minus 0 plus evaluation at 2. Oh. Gosh darn it. There's somewhere. There it is. 16/15 minus the evaluation at 1. Oh, no, I'm sorry. No, check that. This is a completely different equation. Sorry, 2 negative 1/5. Negative 1/5 x to the 5th plus 5/3 x to the 3 minus 4x. All right, now we're cooking. Negative 16/15 minus the evaluation at 1. Negative 38/15. Again, this is all getting multiplied by 2. All right, so let's go ahead and get right down to this answer. So this is 38/15 minus 0 plus negative 16/15 plus 38/15 times 2. Okay, sorry that one took so long. Again, understand the concept. The algebra can come and the calculator can help with your algebra and that sort of thing. But as long as you can set up the problem, that's really the key to success, is setting up the problem. Everything else is just math. All right, you got to understand the concept. Okay, sketch the region of this. So we have a cosine, which looks something like this. And then we have a 2, so that's up to negative cosine, we'll go with this, from 0 to 2 pi. It's supposed to be kind of like a lemon drop. So again, what we're doing is this. We're creating a cosine, and this is up, the midline is up 2, and this cosine will go in the opposite direction. And so it will look kind of like a lemon drop. Lemon. So the interval that we are interested in is one of these guys right here. Something like that. Where this regular cosine keeps going back down, and this one is already. Okay, so this is our area, and so it's the 2 is on the top, the g of x is on the top, the f of x is on the bottom. So this is on an interval from 0 to 2 pi of 2 minus cosine x minus cosine x dx. All right, so this is 2 minus 2 cosine x all right, so this is 2x minus 2 sine x, 0 to 2 pi. 0 and 2 pi are technically the same spot. And this is at 1 and 0, so sines are equal to 0 at both of these places. So this is going to be 2 pi minus 0 minus 0. So this should just be straight up 1. All right, so I'm just gonna do something a little bit off screen here just for a second. Okay. All right, so here we go. Next, wow, I don't really know what that looks like at all. I'm assuming it's in e to the x and with a negative swoop, but we'll just see. Ooh, zoom in there. What the heck is going on here? Okay. Something like that. And we're going from with a y of 0 from 0 to 1. Okay. So it's just going to be straight up the integral of this e thing. Okay, this is going to involve u substitution. 0 to 1 from x e to the negative x squared dx. Okay, again, I can't integrate with the product rule or anything, so this is going to be u substitution. So I'm going to make that negative x squared. That makes du equal to negative 2x dx. Okay, we're in business. I want that to be a 1, so this needs to be negative 1/2. Okay, now I also want to reevaluate my limits. So I see that 1 going in is going to be negative 1, and 0 going in is going to be 0. So our integral updates itself to 0 to negative 1. I know it's backwards, but I don't make those decisions. E to the u du. Now it's never going to go back to the letter x because I adjusted my my limits. It's never going to go back to the letter x. So e to the u is e to the u, and this is from 0 to negative 1. So this is e to the negative 1 minus e to the 0, which is 1. So the answer is going to look, could look potentially a bunch of different ways. So it could look like 1 over e minus 1. It could look like what this would be 1 minus e over e. Or it could look like e minus 1 over 2e. That's what I'm assuming that it's going to look like. I'm assuming that's what the answer would look like, but any one of those is all good. Okay, notice how these are a little bit different. Okay, so to get an idea of what this first one looks like, I'm just going to graph the y's as x's and the x's as y's. So this is x squared minus 2x. Okay, I guess that gives you a pretty good picture. Okay, now you got to think of all of the x's as being y's and the y's as x's. So you see that the vertex of the parabola occurs when the x is positive and the y is negative. Okay, when the x was positive and the y is negative. So think of that in the exact opposite framework. That means the y is positive and the x is negative. So this is technically where that is. And then it opens in the positive x. That means it opens in the positive y. So that's what that picture actually looks like. And then we have y is equal to negative x plus 2. And so that is just a straight equation. And okay, so here is a situation where the top isn't kosher. It doesn't work out. You can't integrate on top of yourself. So here the line is always bigger than the parabola, but you can't. So we have to do it side to side. That's what I'm saying to you. We have to do this side to side. We have to do this with respect to y. Okay, so a few things that we need to figure out. One, what are the y coordinates if I'm integrating up to down, or down to up, I should say? What are those y coordinates? And also, what are the equations that I have to use? Okay, so the first and foremost is the equations. And so that means I need x is equal to. So this first one is good to go. This other one, however, is not good to go. So what I would do is I would, in essence, add x across and then subtract y back across. So x is going to be equal to negative y plus 2. Okay, so now I have these two equations. These are both equal to x, so now I can set these things equal to each other. They're both equal to x, I can set these things equal to each other now. And so I'll move everything to the left, so y squared minus 1y minus 2 is equal to 0. This is y plus 1 minus 2. Thus y is equal to negative 1 and positive 2. What that is we have a positive 2 and a negative 1. That's where these things intersect. I made that picture wrong. I'm sorry. I need you to pay attention to what I said. It occurs in the positive y and the negative x. The parabola exists up here. I'm sorry. And then now we're creating this line that goes right here. Okay. I'm sorry about that. But again, everything else that I said is true. Okay, so this occurs at positive 2. This occurs at negative 1 in the y. And again, it's the line over the parabola. Think of it side to side. Where are the big y's? Where are the little y's? Like, for instance, if we were thinking top and bottom, that's like a big y versus a little y. Here, where's the big x's? The big x's versus the little x's. So it's the right over the left when I set this equation up. Okay, so here we go. We integrate from negative 1 to 2, and the right minus the left. So it's the top minus the bottom. When it's dx, it's right minus the left when it's dy. So here the right is the line, and the line is going to be negative y plus 2 minus the left, which is the parabola, which is y squared minus 2y. Now we're integrating up to down, or down to up. All right, so this is negative y squared minus plus, I got you, plus 1y plus 2. Okay, so here we go, negative 1/3 y to the third plus 1/2 y squared plus 2y. So we plug in the 2. plug in the -1. Seven, six. Oh. I had a feeling that I was doing something wrong. I must have done something wrong. I must have done something wrong. Wow, that's a lot of math to go over. Let me just take a quick glance here. Oh. -7.6. Thank Jesus. All right. Just a button slip snafu. Gosh darn. All right, so that's 9/2. So I did all the math right. I just did the evaluation at the -1 incorrect. All right. Sorry. Oh, that was the last one. Okay. That is it, boys and girls. We will talk about all this in class. Again, if you have any questions, please ask.